Hi, everybody. Randy Dean here. Welcome to something new. Many of you I know me as the email sanity expert and the guy that does the quick tip videos on time and related tech management. But during the pandemic, I got off the road for a little bit. I usually travel a lot, and I had the time to learn a little bit more about Microsoft 365 and Google Workspace, had the time to do a few home improvement projects. But the other thing that I wanted to do was really dive into climate science and take a look at sort of what was going on with the science and the status of climate change. I actually, so much so, I've written the first half of the first draft of a new ebook, and I'll tell you more about that later. Because what we're going to do though is I thought I'd start making some videos on what I found out from this research. And I will tell you that after doing this research, not only do I believe in the science, I actually believe it's critically urgent that we begin acting like right now. But notice the name of the video. It's 6 numbers to prove to me that it's real. I can't make up your mind. All I ask is that you look under the hood, look at the numbers, see what you believe too, and see if you agree with my assessment. So let's look at that first number. All right, so here's that first number. Notice that it's 280. And remember that number. That is the recognized ppm, which stands for parts per million, of carbon dioxide at the start of the Industrial Revolution in the late 1700s. CO2, as it's popularly known, carbon dioxide, is probably the most prevalent greenhouse gas that we are emitting through our use of fossil fuels. And if you remember from back in school when you were young, they talked about how the planet Venus basically turned into a pizza oven because its atmosphere ended up holding in too much CO2. And so when you look at CO2 along with methane, natural gas and water vapor, all of them are powerful greenhouse gases. And actually, we need them in the atmosphere. Without enough of them in the atmosphere, the planet could actually freeze up. That's actually happened at least once way in the past. But if you put too much of these same gases in the atmosphere, it holds in the heat, makes the climate warmer, makes the oceans more acidic, and the weather much, much more variable. Think about how crazy the weather's been lately. So if you haven't heard a lot about it, you're going to be hearing a lot about these CO2 ppm numbers in coming years. Once again, remember, that was parts per million, and it was only 280 in the late 1700s, right as the Industrial Revolution kicked off. Now, the second number after 280 is the number 10,000, and here's why. Prior to the Industrial Revolution, which began in the late 1700s, the Earth's climate had an amazingly stable level of carbon dioxide in the atmosphere. They know that from checking ice core samples from Greenland and Antarctica. We had like almost the perfect amount of CO2 in the atmosphere between 260 and 280 ppm. And it basically stayed there in almost that 20-point range for 10,000 years, which when you think about it, from the Ice Age to up to the late 1700s, that helped lead to the perfect environment for the rise of modern civilization, basically, right up to the beginning of the Industrial Revolution. There was a few warmer periods and a few slightly cooler periods, but it was really in a constant area. And it led to the rise of human civilization, the rise of mass agriculture, the development of towns and cities, trade across countries, and then the settlement of the human species across the entire planet. But then, number 3 hit, and that's 1765. Why is that number 3? That is the year that most scholars point to as effectively the beginning of the Industrial Revolution. It was in that year that James Watt, Scottish engineer and inventor, came up with a breakthrough on the design of the clunky, originally produced 100 years prior to that steam engine. He figured out how to make it significantly more efficient, run significantly better, And that new development allowed for true commercial use in much broader applications. And, it started to have constant continuous improvement by not just James Watt, but other inventors that were coming in. And think about those initial steam engines. What did they turn into? They turned into, the giant boilers that produce the energy from our utilities. They're still basically doing that today. Steam engines, steam locomotives, all of that. And ultimately, it sort of eventually gave the idea that led to gasoline engines using petroleum, gasoline. And then you think about the modern assembly line that was developed by Henry Ford and how things really started to take off. All of this was possible due to those improvements to that original steam engine, coal-burning steam engine, starting in 1765. And that is when the world started using coal aggressively for industry. And it started slow, but it started ramping up pretty quick. We're going to talk about why. Here's why. The fourth number on our list is 7.97 billion. What's that number? That's the current global population as listed in Our World in Data. See, a couple of things happened with that advent of steam power, followed by the ability to have mass electricity and the gasoline engine. And what happened with all of these, it allowed agricultural productivity to take off. We were now able to use large machines to grow more food than we've ever had. And then if you add to that in the 1800s and early 1900s, there was also at the same time major medical advances, perhaps none more important than the discovery of antibiotics and the invention of vaccines. So not only did we suddenly have way more food production capabilities, we also dramatically increased lifespan. It's basically double what it was at the turn of the last century, and population took off. Now, here's something you need to know. I said that the Industrial Revolution began in 1765. Did you know that on planet Earth in 1765, there was less than 1 billion people total? Less than a billion. We didn't hit 1 billion in population until about 1804. And we're just about to pass 8 billion now. So what we've seen is in about 218 years, we have basically seen an 8-fold increase in human population. Now, if you're trying to connect how this matters, here's why. When you have more people, you have the needs for more power, more electricity, and more usage of fossil fuels, coal, oil, natural gas. And so pretty much everything we're doing in our modern civilization still today is running on that stuff. Yes, we've got some new alternative energy options that are starting to come online. We need a lot more of them, but going from the lights in your home to your flat panel TV to your laptop or your phone that you're looking at right now, all of those need power. And a lot of that power is coming from coal or natural gas. The heat in your home, that's probably coming from fuel oil or natural gas. And the gasoline in your car is coming from the oil in the ground too. And all the other transportation options that are using either diesel or regular gasoline. And here's the thing. Every time any one of those things run, from the big industrial sized boilers that provide the power for the electric grid in your city, all the way down to the lawnmower that you're going to go cut the lawn with later tonight, all of those are running off of fossil fuels for the vast majority of people. And every time you turn any one of those on, it starts spewing emissions, including carbon dioxide, into the atmosphere. And here's the thing. I don't think people really get the amount that is going into the atmosphere. It's truly staggering. Now, in just a minute, I'm going to share with you how big these numbers are. But before we do, I want to give you some context. Our fifth number is 421. What's 421? That was the average atmospheric carbon dioxide ppm recorded in May of this year in Hawaii. They do most of the measurements at one of the top of the volcanoes out in Hawaii to make sure there's consistency. And here's the interesting thing. So think about this. We were at 280. Now we're at 421. So in 250 years, that's the beginning of the Industrial Revolution, we have increased the level of the most prominent greenhouse gas, carbon dioxide, by 50% in 250 years. And that is after having a 10,000-year period where it stayed in a 20-point range. Fluctuated up and down a little bit. It was in balance. The planet was in effective carbon dioxide balance. And then we turned on all of those engines. Oh boy, what did that do? Let's talk about that. And here's my final number of the 6. It's 36.3. Now, that's a pretty simple number. Not a very big number until you realize what it actually means. 36.3 is the number of metric gigatons of carbon dioxide that was emitted by all human and industrial activities. But wait, let's get clear on what a gigaton is. It's 1 billion metric tons. Okay, so 36.3 billion metric tons. Hold on, wait, there's a kicker. That isn't how much we've put into our atmosphere since 1765. That's how much we put in our atmosphere last year, 2021. We put 36.3 billion tons of CO2 into our atmosphere last year alone. Let's talk about that. Let's consider 36.3 gigatons. Just think about this number. It's such a big number, most people can't even comprehend a number this big. Look at that. That's 36.3 billion tons. There it is in numbers. That's how many zeros in a billion tons. But wait, if you actually take it all the way down to kilograms, because remember, these are metric tons we're talking about, it's 36 trillion 898 billion 950 million kilograms last year. And I know a lot of people from the United States are watching, so they're trying to do the metric conversion. Let me make it easy on you. Each metric ton is 2,204.6 pounds. So if you do that conversion, it's not 36, trillion pounds. No, it's 80 trillion pounds last year from running all those engines. Just last year. It is just so hard to even understand and try to comprehend numbers this big. So let's give you some reference points here. What weighs a metric ton? There's a few things that might give you some perspective here. You remember Herbie the love bug? Well, he probably weighed about a ton. An adult male walrus, and a pretty big one, that weighs about a metric ton. And two heavy grand pianos, the nice ones. And so now just think about that for a second. That is 1 metric ton. And now picture 36.3 billion adult walruses floating in our skies, or 36.3 billion love bugs floating in our skies over our heads. That's what we're putting out there every year, every single year now. And it's just mind-boggling when you try to consider the size and scope of what we're putting into our atmosphere at still an increasing rate. You know, we're proud of ourselves. We're patting ourselves on the back. Hey, we slowed down the rate of increase. We need to be going the other way. Let's talk about that. Up until 1765, we had a global atmospheric system that was basically in balance. But you got to remember, even though planet Earth is huge, the atmosphere is just a thin sliver above that giant ball. And it's the sliver that all life depends on. And I understand that the planet is big, but those numbers are big. And if you have a system that is in balance, and then all of a sudden you start adding in an extra something to that system at these scales, it's going to go out of balance. And the plants, the rocks, and the oceans can't keep up with this level of emissions. This is what we've been doing since 1765 when we turned on those coal-burning steam engines. And we've morphed into gasoline and diesel oil and, natural gas, all of them emitting. And here's the evidence. Now take this in. Look at these numbers too. Notice that I got one from NASA, one from NOAA. And here's the interesting thing. These numbers are just since 1880. That's about 100 years after the start of the Industrial Revolution. So we already had 100 years where we'd been putting this stuff at an increasing rate into the atmosphere. And just since 1880, we're up about 1.1 degrees Celsius, or about 2 degrees Fahrenheit. We've also added about 8 to 9 inches to our sea levels. But now here's the interesting thing. If you look at the models and the estimates, we're now seeing estimates of anywhere from 2 to 6 degrees Celsius of total warming by the year 2100. And that's all dependent on how well we curb our emissions. A lot of these models are making the assumption we're going to curve and go down. Okay? If we don't do that, we're going to be closer to the 6. They're also making the estimate of 1 to 3 feet of additional sea level rise, although there's one new model that just came out that shows if we keep increasing the greenhouse gas emissions on the line that we're on, it could be closer to 6 feet or 2 meters higher by 2100. Now I want you to think about all the news you've been seeing about the Doomsday Glacier in Antarctica and the rapidly increasing ice loss in Greenland. I might do a video on both of these in the future. The amounts are staggering. But the rate on both of these, temperature increase and sea level rise, are accelerating. The vast majority of these rises have happened in the last 50 to 100 years at an accelerating rate. So why does this matter? Well, let's just take one very specific example. And remember, this is just one. I mean, the increase in frequency in droughts, the increase in frequency in massive wildfires, simultaneously the increase in rainfall and floods in other regions. Some places getting drier, some places getting much wetter. The rise in the sea levels could potentially flood coastal cities. High tides are now going to cause flooding events. Who knows what's going to happen? Big hurricane comes on shore with storm surge, with this higher level of water. But these aren't even the things that have me deeply, deeply concerned. There's one major factor that I'm concerned about. And what it relates to is the fact that there was one study that recently came out that said there's a high probability of crop failures beginning between 1.5 degrees Celsius and 2 degrees Celsius. Massive crop failures could begin there. We're at 1.1. 1.5 to 2. Now you're probably saying, well, how can that small of a change make a big difference? Here's why. Spring starts earlier, fall starts later, more droughts, more floods. random freezing events coming out of nowhere late in the spring season or early in the fall harvest. You know, you change the climate of a region, the crops that used to grow there are going to have a hard time growing there with these new numbers. Another study predicted that for each degree Celsius we warm, our breadbasket crops of wheat, rice, and corn will lose somewhere between 3 and 7% of their crop for each degree of warming. Now, when you think about this, this is 3 to 7% per degree, and we might go up 3 to 6 degrees if we don't make pretty significant changes to our global economy and infrastructure. Here's the issue with this. And by the way, there's yet one more study that came out not too long ago from, I believe, the University of Washington that found that it might even be much higher in the temperate regions, these crop losses, because as the temperatures warm, insects become much more active. They need to eat a lot more, and they multiply more quickly. So they're thinking that the crop losses could be significantly higher than the 3 to 7% per degree. Could be even more. Famine and infestation. That sounds like fun. Now, we don't know for sure when it's going to happen and when we're going to start seeing major drops in productivity loss. But we do know that pretty confidently, we keep warming things, we're going to start to see crop losses. And when that happens, you can see how it's going to be really hard to be a successful farmer or farm operation in the place that you've been farming for potentially generations. But that's not even the thing. I mean, this is going to affect all of us, because if we see big drops in the major breadbasket crops, corn, rice, wheat, that's going to hit all of us. There goes the global calories. And you got to remember something. Money is basically worthless when there's no food. And don't forget this also. Projections between 10 and 11 billion by 2100 is our population. So we're looking at a situation where we're going to have, 25 to 30% more people on the planet with 25 to 50% less food available. That sounds like a train wreck. Remember, it's a train wreck that we can see is coming. It's coming down the tracks. It's coming right at us. We can make the change. Now, like I said at the very beginning of the video, I can't change your mind. That's up to you. Do the research, see if you agree with me. But when I start doing the research and finding these facts myself, which is what I encourage you to do as step one if you still are skeptical, get under the hood and look at these things. And I challenge you to do this. I'd also say be careful trusting people that tell you there's nothing to worry about, because it's coming fast. And I have to question their motives. Are they driven by greed or ignorance or a combination thereof? What is it that's making them say this is no big deal? Because it's going to clearly become a big deal. And if you agree that this is a big deal and getting much worse, do your best to educate those around you with your research and advocate. Don't just try to make personal change. That's great. I hope you do. But what I want you to do is get in touch with the companies, the utilities, and your local, state, and federal governments, and make sure they understand the science and also make sure they understand the urgency. Hopefully they'll start making policy changes and law changes that will give us a chance. And hopefully the corporations will also just start quickly moving in a more green direction and a lower emission direction, if not a zero emission direction. And, maybe start making some of those personal changes now. If you're up for a new car, seriously consider a hybrid or even a full electric. Watch for the hydrogen vehicles that are going to be probably coming out pretty soon. Try to look at your home and business energy usage. See what you can do to make changes on that. Possibly look at a solar array. Start growing a garden, planting some trees. I mean, every little bit we do will make a difference, but we got to start making that difference fast. Now, like I said, this is my first deep video on this topic, and I hope that you see why when I put all those numbers together, I'm like, wow, this is a big deal. It's happening fast. And when you think about the fact that, if you take that 36.3 billion metric tons from just last year alone, what that means is in less than 20 years, we're putting a quadrillion pounds of stuff in our atmosphere. That's just crazy numbers. It's going to affect a thin layer, the layer, though, that we depend on for our life and our productivity and prosperity. So if you like what I'm doing here, I've actually written, like I said, the first draft of an ebook. I'm going to be posting information on how you can get that on a little website I've created called climatehottopic.info. I've also created a Facebook group. And if you are energized and want to do something, please follow up with me, leave comments to let me know what you're doing about this stuff, and also start engaging. It's going to require all of us to be on board here. And we really got to get to the people that are just ignoring the urgency and try to get them to understand why this really, really matters. I got 2 little girls. They're not so little anymore, but I want them to have a future. And it's kind of hard to see a good future with everything I just shared unless we make big change soon. Thanks for watching all the way to the end. I appreciate it. If you like this, please let me know and watch for more. I'm going to create a playlist, Climate Hot Topic playlist from my YouTube channel, and I'm going to try to start very frequently making more videos on this topic. Thanks for your time and attention. Bye now.